Hey Algebra, it's Mr. Mock, and we are into week 8, if you can believe it. And this week we're solving quadratics using square roots. So I just want to review what is the solution of a quadratic, all right? For a quadratic, the solution is where the parabola crosses the x-axis. All right, that's what we're looking for, okay? And there's variations of what a quadratic looks like, but in order for it to be a quadratic, the highest degree needs to be squared, okay? The polynomial has to have an x squared and has to be the biggest, right? So you can have anything that looks like x squared minus 7x plus 2 equals 0. That would be something that would be a quadratic. You could have x squared plus 6 equals 0. That would be a quadratic that we could try to find the solution of. Basically, it has to have an x squared. It doesn't have to have an x. It doesn't have to be a trinomial. It doesn't have to be a binomial. You could have a monomial. You could simply have negative 22x squared equals 0. All of those are quadratics, okay? So for us, in order to be able to solve a quadratic using a square root, you need to have something like this. These will work for solving with a square root. All right, so the process I'm showing you today is only for ones that don't have an x in it, where it's just an x squared and a constant, or an x squared, no constant. Okay, so that's what we're looking for. So examples. I've got 4 of them. First 2, straightforward. The next 2 get a little bit more tricky. All right, so for this first one, you have x squared equals 64. Okay, the only way to undo an x squared is to do the square root of it. So you would do the square root of x squared. And as is the case with any equation, what you do to one side, you do to the other. So you have to do the square root of 64. Okay? Now here's the part that people typically forget, all right? The square root of x squared is x equals, now, the square root of 64, most of you are going to go 8. And you're right. But there's also another square root of 64. And that's a negative 8. So you could write it as x equals 8 and negative 8, or what you're going to start seeing is this symbol here. It's a plus or minus 8. Okay, so that would be the answer for problem number 1, which means if you were to take this to Desmos and do y equals x, or x, type in x squared equals 64, you'd get a parabola that crosses here at the plus or minus 8, or actually you would probably type it in as y equals x squared minus 64. And then that would give you, right, because then you'd add both sides, right? Or when is it 0, da, 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 da. Okay, and then you would see this, and it would be great, and everybody would be happy, okay? So number 2, here. It's set equal to 0, but it only has the x squared, okay? It doesn't have the x in here, which says, hey, we can solve this using square roots. So I'm going to subtract the 36 over. So now I have negative 1/2 x squared equals negative 36. In order to solve this, I'm going to multiply by negative 2 on both sides. So now I have x squared equals negative 36 times negative 2 is going to be 72. And now I'm going to do the square root. And I do the square root. Okay? So I'm going to get x equals the square root of 72. No, right? That doesn't work. But we have to now think about what we did last week. How do I break down the square root of 72? I can break that down into the square root of 9 times the square root of 8. I can break that down further into the square root of 9 times the square root of 4 times the square root of 2. So now what I get is the square root of 9 is 3, square root of 4 is 2, times the square root of 2. 3 times 2 is 6. I have to remember the plus or minus. 6 times the square root of 2 would be the answer for number 2. So what we did last week is going to play in to what we're doing this week. We're breaking down those radicals, okay? Now, number 3. Similar to number 2, add 19 to both sides. You get negative 5x squared equals, let's see, that's 13, 5, 6, 163. Then you divide by a negative 5, so you get x squared equals negative 163 fifths. And do you notice anything? We're done, okay? And I'll explain why. I can't do the square root of a negative. That's not in the skill sets that we have just yet. When you get to Algebra 2, we'll talk a little bit more about what the square root of a negative actually does. But for right now, this means there's no real solutions. But Mr. Mock, what does that mean for the parabola? If I'm graphing this, what does it mean if it has no real solutions? That means the parabola doesn't cross the x-axis. So I want you to kind of envision what that would look like. In this case, we see that there's a negative in front of the x squared, so because we've done such a good job graphing, we know that it goes down. That means the parabola opens up down. Whoop, whoop, whoop. And so that means that it's going to be below the x-axis, opening down. So it's not actually going to touch the x-axis. So that means there's no real solutions to this one, okay? They'll just be imaginary solutions. What? Okay. Now, number 4. Another skill that we need in this one. I'm going to add 7. Add 7. You get 2x squared equals 45. Divide by 2. And what you get now is x squared equals 45 halves. Don't you dare turn this into a decimal. Please don't turn it into a decimal. Absolutely, positively, do not turn it into a decimal. Now we do the square root, okay? And the way that I show this is this way, like that, okay? So you're going to get x equals plus or minus, and now we have quite a bit of work ahead of us, all right? And you're not going to like it, but we just have to. It's called rationalize the denominator. I have a square root of 2 in the denominator right now. I don't like that. We don't leave square roots in the denominator, okay? So we're going to do a process called rationalizing the denominator. And Pearson asked you to do this, so I'm making sure to show it to you now. In order to rationalize the denominator, I want you to check this out. We're going to multiply by 1. Do you see this? Square root of 2 over square root of 2 is 1, right? Any number over itself is 1. So we're multiplying by 1, which leads us to the square root of 2 times the square root of 2 is the square root of 4, which is 2. So notice how we unlocked the denominator. It no longer has a square root. So we accomplished our goal. And now we have the square root of 45 times the square root of 2, which is going to be the square root of 90. Now, we're still not done. And I know some of you are going, well, I don't like it. It's so that it's the square root of 45. No, don't do that to me. This is not under a radical. This one is, so you can't simplify it. But we have to simplify the square root of 90, which means we have to go back to doing this process, okay? So simplify the square root of 90, and, well, just for fun, I'll just come over here. Square root of 90, well, that's the square root of 9 times the square root of 10. I know the square root of 9 is 3. I don't know the square root of 10. Can't do it, can't break it down any further. So what you get then as your final answer is the plus or minus 3 times the square root of 10 over 2. Mr. Mott, can't we make this 5? No, don't do it. This is not under a square root as well. So you cannot simplify this. Okay, team. Just over 10 minutes. Bummer, I was trying to be at 10 or below. But those are 4 examples that you absolutely need to see. You also need to, revisit the Pythagorean theorem. The hypotenuse is always the c. Hypotenuse is always the c. You'll need to use Pythagorean theorem again this lesson. So it'll be 10 minutes and 30 seconds. Peace out, guys. Bye.